Hi, Victoria. How are you? Hi,
Good
Brian.
morning.
How are
Very
you?
well, thank you. How are you doing?
Yeah, I'm okay. Thank you. Hi, Ankit. Nice to see you here. Hi, everyone. Welcome.
Hello, everybody.
How was your day? Everything good, everyone?
Very well, thank you, Katerina. Yourself?
Good. Thanks. I'm really excited about this, especially based on the discussion Serena and I had yesterday. I'm looking forward to this talk. So.
Katarina?
Yep.
Somebody else is on stage with us?
Oh, there's?
Are they?
I just see the three of us right now.
Okay, I only see the two of us. Maybe I better leave and come back. That's really scary.
I heard that a bunch of people are having these issues with the new update here, so you're not the only one.
Unless it's a new invisibility cloak feature that we haven't gotten yet. Okay, I'm going to leave and come back.
I'm just seeing 3. Yeah. And that was a really good room last night. That was really fascinating. I'm going to listen to the replay of that, Katerina, talking to Serena about that.
And Keith is here, the first author of the paper that we discussed yesterday. He's in the audience. So welcome.
Welcome. Thank you for joining, everybody, at the Science Society, and we're probably going to be starting in a few minutes when the guest speaker arrives. So everybody get comfy and get ready for a fantastic time.
Jamie, you make it sound like there's going to be popcorn.
Yeah, with Science Society on the box.
Exactly.
But don't turn off your phones, though.
Yeah, but this is the good thing about not having a video, right? You can just relax and I think it's more relaxing to not have a video on.
Absolutely, you can let your hair down, metaphorically and literally.
So tonight we don't have a room planned, but I'm open for discussions if anyone wants to have like just a general discussion room. We can certainly open it up or update ourselves on what's have been published this week out there. So
You know me, Katerina, I'm always up for a good chat about everything that's happening. So I'm in, if anyone else wants to.
hi, Eric.
Hello. I just wanted to mention about dogs. Like, it's completely obvious they get jealous, right? Like, that is envy, is definitely an emotion dogs have.
And I read that they get like, for them it's very stressful to have this emotional pressure to be a good dog. I think. Oh, hi, Dr. Kunguo. Thank you for coming. Welcome. I see you on mute, but I cannot hear you. So maybe it's the headphones, or some headphones are making issues with the Clubhouse.
You might try leaving and coming back. That's another fix. Just using speakerphone or leaving and coming back.
Or sometimes it's the
Yeah.
Wi-Fi. If it's a public Wi-Fi that blocks social media usage, that can also be an issue sometimes.
Welcome to Audio Tech Support in Clubhouse. We're happy to serve you. Welcome, friends. Lauren, Prasad, F, Ankit, Brian, Kun, Eric, Jamie, Katarina. Oh, I hear some sounds. I hear some background noise, but not the mic.
Hi, can you hear me?
Yes, perfect.
Okay, brilliant. Yeah, I'm switching to my PC, so hopefully a big screen.
Excellent. Welcome.
Okay. Yeah, it's like 2 minutes left. Let's wait another couple minutes to give people time to arrive. We scheduled it at 1 p.m. EST. And in the meantime, Kun, did you have a good day? For you, it's already evening, so I hope you had a good day today.
Yeah, Friday is always good. But unfortunately, Friday normally is my meeting day, so we have endless meetings.
Kun, what part of the world are you in now?
Me? Yeah.
Yes.
I'm in UK.
Okay, so
So it's a
6.
city called Lincoln.
Mm-hmm. So you're coming on evening.
Yeah, it's
Yes.
5 hours, right? It's 5 hours different.
Yeah.
Well,
so we are approaching 6 o'clock.
right, yeah. Well, unless you're on the West Coast.
Right. For
Well,
you,
then good evening. Good evening.
Victoria is on the west coast, so for her it's 3 hours more, so it's 8 hours difference. You're right.
America's too big. Far too big.
So, Kun, I have a question. Do you have dogs?
I used to.
Okay, that's...
Yeah.
yeah.
So when I was young, my parents, we had cats, dogs, guinea pigs, rats. But I moved to UK and I got married. So unfortunately, my wife, she's allergic to hair. Yeah,
Oh,
so don't keep pets at home. Yeah.
what about the... Oh, it's hair, not fur. So you can't even get the not fur dogs, like the poodle or... It's the
We
hair.
could, yeah, but it's
Yeah.
kind of risky. But for me,
why try? Yeah.
because we have a big group in the university. So during the daytime, so if I want, so I can play with the dog for many hours
Right. So you can still find
as a
dogs.
conversation.
Well, that's interesting that you had rats. It's unusual. I have in my family, and I find that rats are they're really great companions. They're like small dogs, and it's astounding that they live such short lives because they're so responsive and affectionate and really sweet and fun and adorable.
Yeah, and they are always energetic. Yeah, so you can always watch them to play around.
Okay, I think we can start. Hey, Wisdom, welcome. Welcome to the stage. How are you today? Hi, Frank. Thank you. Everyone. Glad to see so many of our friends here. Thank you. Okay, welcome everyone to the Science Society here today. And We are very happy to introduce you to our guest speaker here, Professor Kun Guo. And let me give you a little bit about some information about him. He is a professor of cognitive neuroscience, School of Psychology, College of Social Science in the University of Lincoln in the UK. And he received his bachelor in human psychology from the Nanying University, and he did his PhD in cognitive neuroscience from the Chinese Academy of Neurosciences. And before he came to Lincoln, he worked as a McDonald Pugh research fellow in the University Laboratory of Physiology at the University of Oxford. And he was a research associate in the Department of Psychology at the University of Newcastle. And his main research focus is in cognitive neuroscience of vision, social interaction, emotion, human-animal interaction. And he received several awards throughout his career. And it's a really great honor to have you here today. And if it's okay, Victoria will ask you first a couple of general questions, and then the stage is yours to go over your presentation. Thank you.
Yeah, sure. Thank you. Yeah.
Thank you, Katarina. So, Kun, welcome. Science Society is so glad to welcome you here today, and we appreciate all the time that you are about to spend with us, and hope you have a good time too. I'm interested in learning about how people find their way to science. And so my question to you is, can you, if you reflect on your life, even your childhood, can you think of a time that you recognize that you felt a spark of interest in science and you were really drawn to the sciences?
Right. It's a very interesting question. Right. I have to think hard to go back to my youth. Uh, yeah, I guess probably.
Well, I
Yeah,
don't
I
know if it's
think.
just
Yeah,
me, but Professor, you're very, very quiet. Is everybody else hearing like very, very quiet? No?
I'm very quiet. Yeah, I'll try to move my
Is this
microphone
just
close to
me?
my mouth. So how about now?
A
That's
little bit
better.
loud. Yep.
Yes, your volume was a bit low. Thank you, Jamie. It was a
Okay,
little
yeah.
low.
I'll try to increase my. Yeah.
Thank you.
Right. Yeah. So I think I started to get interested in science when I was in secondary school, probably around 13, 14 years old. So what I found at that time is the science subjects like physics, chemistry, biology, uh, they are easier for me to follow because you can find some kind of regular pattern in the subjects. So unlike more humanity-based subjects, which is more need more creativity. So for science, basically I spend less time to get a high grade, so which leaves me more time to play games. Yeah, I guess this is why I was interested in science subjects while I was in the middle school.
Thank you. That's fascinating. And it speaks to how important it is for each of us to find their path and to be able to follow what truly interests each of us. And so my next question is, how can you please describe the path that led you to your current research?
Right. Again, that's a great question. Uh, so I think I have my group has a broad range of research topics. Human-dog interaction, I guess, is my personal interest based on two reasons. So one is curiosity. So like I mentioned to you earlier, I used to have many pets at home, and I was also curious. So when you play with your pets, so what do your pets think about you? So from their perspective, in their eye, who are you? What are you doing? So that's a question always interests me. So that's from a personal interest out of curiosity. Uh, Another reason for me to get into human dog interaction is because of my background. So my training is cognitive neuroscience. So we're interested in how human brain works. And our end goal is to find some sort of intervention to help people with different brain damage or brain problems. By doing so, you really need some kind of animal models to mimic human problems. For me, I think if you compare with other species, dogs probably are very rare species, probably the only one, which fully share human environment, our family environment, and especially our social environment. So from this perspective, if you think about human social problems, like a neurodevelopmental disorder such as autism, for adults like anxiety disorder, depression. So this kind of mental health related neurological disorders. Uh, Dogs probably can better represent human mental health issues. So uh, from a scientific perspective, I think yeah, dogs will provide us a unique window to understand more about human social related um, brain disorder. So I guess that's the two reasons for me to get into this kind of a human-dog interaction research.
Right, and the affinity is strong, and
Thank you.
yeah, thank you so much. At this point, you're welcome to begin your discussion of your work, and if you'd like to carry out your discussion and then at the end have a question and answer, that's our usual format. Some guests prefer to have questions along the way as they're delivering their talk, so that's entirely up to you. And so you can choose what you like, and please begin your discussion. And thank you so much.
Okay, thank you. Yeah, thank you for this opportunity to share my research with you guys. Uh, so in terms of the format, I think I'm going to discuss my recent work on human-dog interaction for about 15, 20 minutes. Then, yeah, I'm happy to answer whatever questions you want to ask. Um, but because I don't know uh, whether what kind of details I've approached. So if I use the terminology, if you can't follow my story, yeah, feel free to interrupt me. I'm happy to answer your questions along the way. Yeah, so I'm flexible.
Thank you very much. And if I may just interject, when we do bring friends up, that when you have a question or even now, that you please flash your mics so that we can then pass the mic to you, just so that it doesn't become a free-for-all. So thank you. And then we can be fair and make sure everyone's voice is heard. So thank you so much. And off you go, Kun.
Okay, yeah, thanks. Yeah, so the topic I want to discuss with you is can dogs read human emotions? Uh, Before I start to talk about my own research, so a little bit of background. So I try to convince you why this topic is interesting and is important for humans. So perhaps, yeah, we all have noticed, especially for the last few years, we have a hugely increased number of dogs in our society. So in the UK alone, at the moment, we have around 12.5 million dogs in the UK. And they serve multifunctional societal roles, such as pets, protection dogs, searching dogs, assistant dogs. And especially for the last 10 years, perhaps you have also noticed, dogs are increasingly introduced as therapy dogs. Uh, in our school settings, hospital settings, and care home settings. And so, from this perspective, we can argue dogs have a great social and ecological value to our society. And the numerous research have reported they can provide a significant benefit to human development, and also to our physical and mental health. And because we have so many dogs in our society and they play important roles, then you can argue and to ensure we have a good relations or good interactions between human and dogs and high levels of dog welfare. So ideally, we should understand each other's emotional state. We understand dogs and vice versa, and dog can understand ours. So before we talk about how dogs understand human emotion, so if we think from our own perspective, so how we understand as a human, how we understand each other's emotional signals. Okay, so we know we are really good at reading each other's emotional expressions, especially from the face, because this communication is so important for our social interaction, for our survival sometimes. So human, we have developed a specific cognitive strategy, and we have dedicated neural circuits in our brain and in processing human emotional cues. Okay. So my question is, can we find similar mechanism across mammals? So this idea is very attractive. So I'm sure we can all appreciate it. If we can understand animals' emotion and animal can understand ours, so maybe we can make our world more interesting. So this idea actually was originally proposed by Darwin. So he argued because you can find many evolutionary origin in human emotional behavior, and also in the way we move our facial muscles. We control the muscle movement in our face and in our brain to process emotional cues. So maybe this homology in emotional behavior, in the way we control the facial muscles, and can can across all the mammals. So as a result, maybe animals, especially social animals like dogs, can use more or less the same strategy to understand human emotion. So that's a very interesting proposal. And across all the animal species, so one unique thing about dog is a co-evolution. Okay? So our recent evidence, genetic analysis, suggests that maybe dogs, they are probably the first domesticated around 23,000 years ago. Okay? So through this long history of interaction with humans, so surely maybe dogs can develop some way to understand humans. And humans maybe can also develop certain ways to understand the dogs. Okay. So that's the co-evolution idea. And there's another factor may contribute to this human dog understanding is selective breeding. Selective breeding perhaps is not very, how can I put it in a nice way? Uh, so we're very human way to use a dog as a pet. But since Victoria time, probably 200 years ago, 180, 200 years ago, humans start to breed dogs selectively according to certain traits. So as a result, you add another level of pressure to dogs' ability to understand humans. So bottom line is this different pressure or different factors may encourage dog to develop some strategy to understand the human. So that's why we use a dog as a model to study human-animal emotional understanding. So we can argue theoretically, yes. So animals, especially dogs, should be able to understand human emotion. The question is, how are we going to test it? The straightforward idea is we can ask owners. So we can ask owners how many dog emotions you can detect, and from your perspective, how many emotions your dog can detect from you. So we can do this kind of simple study. But the issue is owners report they are biased. So which means how reliable the data probably is a question. It's questionable.
Sorry, if
So
I may, I just I'm having a hard time hearing you. I don't know if it's perhaps you're wearing a headset or just moving away from the microphone, but is there any way that you could speak a little louder?
okay, yeah. Let me check my volume. It's 100%. So how about now? I put the mic very close to my mouth.
Yeah, that's a little better. But in general, the app just doesn't work that well with headsets.
Okay, yeah.
Um,
So I'll speak directly to the microphone in my computer.
Thank you very much, Kun.
Yeah, but sometimes they may come echo.
Ooh.
So how about now?
Yeah,
oh, yes,
Too loud?
much better.
yeah, we hear the
Okay, yeah.
echo, but maybe it's a chance we'll take so we can hear you louder. Thank you so much.
Okay. Right. Yeah. So we have to find some objective way to test dog's ability to understand human emotion. There are quite a few research in the past focusing on this topic. They tend to use, we call it associative learning, to test the idea of dog's ability to understand human emotion. The typical example is to use a touch screen. So if you train the dog to learn some kind of association between happy eye and a happy mouth. So dogs understand happy eyes looks like this, happy mouth looks like this. So once dogs can learn this kind of association, you present a happy eyes, then you put a few mouths together, dogs will go touch the happy mouth. So from this perspective, you can argue, in dog's mind, they know what a happy face looks like. So that's a happy eyes and happy mouth. So that's one common protocol people use to test dog's ability to understand human emotion. The issue for me is this kind of approach, you need first extensive training. The training in animals can cause a bigger problem. So what are you training for? So that's a problem for me. So in this particular case, it's very likely dogs can learn to discriminate certain features. There's a happy eyes, there's angry eyes, there's a happy mouth, there's angry mouth. But they don't necessarily know what happy means or what angry means. So if you use a training approach, so maybe you want to test dog's ability to understand emotion, but at the end of the day, you're testing dog's ability to discriminate different facial features. So that's a problem for training. So what we hope is to find some kind of protocol to measure a spontaneous behavior from dogs without any training. And also we want to measure ability of categorization rather than the visual discrimination. The dogs can categorize the happy, angry, disgust, rather than differentiate between happy face and angry face. So that's our hope. So to find a suitable protocol, we looked at human infant studies. So in humans, we have this kind of, we call it a cross-modal sensory integration. So we can combine our visual inputs with our auditory inputs to understand the meaning of the word. Okay. So this kind of cross-modal sensory integration typically will provide a faster, more reliable, and a more accurate recognition. So in emotional research, so if I give you this example, so for instance, you hear a happy sound and you look around, so most likely you will focus on the happy face, try to find who is laughing. Okay. So you can match happy sound with a happy face. So that's a typical example of a cross-modal sensory integration. So to do this, we must have some kind of template in our mind to understand the meaning. So what is a happy sound? What is a happy face? And what is the relation between happy mouth, between happy face and happy sound? So you have this kind of internal representation of different emotion categories. So we think, perhaps we can use this cross-modal integration to test our idea about dog's ability to understand human emotion. So I put a video clip in my slides, so probably you can take a look when you have time. But I can describe the setup. So what we did is we put two faces side by side. So one is a happy face, one is an angry face, side by side. So at the same time, we deliver a sound, a vocalization. So could it be a happy sound, could it be an angry sound, or could it be some random noise? Okay. So what we want is to measure dogs' looking behavior. So imagine from your perspective, so if we have two faces in front of us, one's a happy face, one's an angry face. At the same time, we hear a happy sound, people laughing. So automatically, we will direct our attention to the happy face. We try to find out who is laughing. So that's human behavior. So we try to see whether we can find a similar behavior in dogs. So we used a human face and a happy face. And to avoid the training, so we used unfamiliar human face and unfamiliar dog face. And also to control any possible training experience. So we ask people to speak in a different language. So fortunately, the student did this study, she's from Brazil. So she can speak Portuguese. So she called dogs come on in Portuguese in either happy sound or upset sound. And we are testing British dogs recruited from Lincoln. So hopefully these dogs, they don't have much experience to hear Portuguese at Lincoln. So through this kind of protocol, we found dogs tend to look at the face with the expression can match the vocalization. So if dogs hear the happy human sound, the dogs were more likely to look at the happy human face. If dogs hear happy dog sound, more likely dog will look at happy dog face. So we found this kind of behavioral tendency, more or less like a human infants. So as a result, also we found there's no preference to different. In other words, this tendency is not affected by the face species, either human face or dog face, or by the valence, happy face, angry face, or by the gender, male face, female face, or by the location of the face, left or right. So that's all the control experiments. So as a result, we can be more confident to say dogs can really match happy face with a happy sound or angry face with an angry sound. Okay. So to do so, most likely they have some kind of mental representation about the different emotion category. So that's our basic finding from that experiment. So we argue as a species, dogs, they possess at least some mental prototypes for emotional categorization, such as the positive and negative balance. So that's our conclusion. Then the next question is if dogs can understand human emotion, so what kind of strategy you use? So that's our next question. So again, before testing dogs, we start to think about how human understand human facial expression. So we know, if you imagine yourself, okay, so when we try to display different expressions, happy, angry, disgust, fearful, we tend to move our facial muscles in a certain way, in a certain configuration. So as a result, our different facial features, eyes, nose, and mouth, they can be more representative for certain emotion. So for instance, if you want to look for a happy face, perhaps you will concentrate on the mouth. If you look for an angry face, perhaps you will concentrate on the eyes. Just through our experience, we know that's the most useful region for us to detect other people's facial expression. So that's how we read each other's facial expression. So our question is, do dogs use more or less the same strategy to read human facial expression? So in one experiment, we present video clips of different human and dog facial expressions, like happy, angry, fearful, and so on, and monitor human and dog's eye movement, so we can understand which part of the face they tend to focus on when they look at happy emotion, angry emotion. So again, I put a clip in my slides. So if you can access the slides, so you will notice on the screen, so you have one side is a human, look at the human face, other side is a dog, look at the same face. Okay? And each dot on the screen represent a gaze point or fixation from either humans or dogs. So hopefully you will notice dogs, they tend to use a different strategy to look at human or dog facial expressions. And we did many detailed analysis, and we can conclude there's no human-like face reading strategy in dogs. Okay. Now the next question is, if dogs use a different strategy to look at a human facial expression, look at human emotion, then what kind of cues they use? So in a different experiment, we present the whole body to both humans and the dogs. So again, if you can see the slides, you'll notice on one side is how humans look at human emotion, on the other side is how dogs look at the same emotion. And each dot represents one fixation from one dog. So hopefully you can get this impression. So when humans and dogs look at the same emotional cues, humans tend to look at the face a lot, but dogs, they tend to look at bodies a lot. Okay. So again, we did many detailed analysis afterwards, and we can conclude that dogs, they use bodily cues more often than humans to pick up human and dog emotion. So through similar research from my group, I think we can reach this conclusion. So if you compare dogs and humans' ability to understand each other, so we can say they are qualitatively similar between dogs and humans, but with marked with very clear quantitative difference. Okay? And the sensitivity to read emotional expressions between humans and dogs and their species are context dependent. And we do have some kind of innate and experience-driven strategy to do that. The bottom line is I would argue we can't understand between humans and dogs. It's unlikely we will understand each other's emotion and automatically. So what we need is some kind of a social learning strategy to better understand each other's emotion. So it's not an innate behavior. It's more like learned or trained behavior through human-dog interaction. Okay. So that's my story so far. So thanks for your interest.
Yeah, thank you so much for this wonderful presentation. It's such an interesting work, and it's amazing how dogs co-adapt with us. Yeah, please go ahead, everyone, with questions. Flash your microphone if you have questions. Serena, go ahead.
Yeah, no, it's a fascinating topic, and to try and analyze, how that works. I'm curious, have you looked at whether there's a regional correspondence in fMRIs between the dogs and humans in these types of activities? I'm aware that fMRIs interpreting those signals, maybe more indirect in inferring, neural firing patterns, but it may be a more of an indication in astrocyte activity. So I'm
Yeah,
curious what kinds of correspondences that might be there.
that's a great question. It's something we are aiming to do, but we are more from humans' perspective. The issue is for humans, we know exactly the different neural circuits, the function, the connection for different neural circuits. For the face perception, so perhaps so in case we call it a core system and extended system, we know the connection, we know the individual roles for individual brain regions. So as a result, we can find some kind of correspondence. One human try to understand human emotion and a dog emotion. So we can compare differences and similarity. So that's our current work. It will be extremely interesting if we can do the similar things on dogs. But we do have a huge challenge in front of us. The first is training. So what can you do to enable dogs can lie still in the scanner for a few minutes? That's a big challenge for us. So at the moment, there are two groups are working on this, and because it's very difficult to control the mobility, as a result, you don't have many good signals from dog's brain. So that's the first challenge, the practicality. Another challenge is brain mapping. So that's another big challenge for us. So for humans, we know the brain structure, we know the organization, we even know majority of the brain areas function, but we know very little about the dogs. So roughly you know the parietal, temporal, the big regions, occipital cortex, but for which part of area is involved in the face perception, what area is involved in emotion perception. So what's the link between the face perception and the emotion area in dogs? We have no idea about this. So we don't even understand the basic in dogs' brain structure and the potential neural mechanism. So that's another big challenge in front of us. And I think technically it's doable, but yeah, I'm sure we can understand. If we want to do this, there are many ethical issues in front of us. Yeah. So how many invasive approach can you use? how long you can keep a dog in the scanner without affecting their welfare. Yeah. But it's a good question. Unfortunately, we can't give you more direct answer about this from a dog's perspective.
Yeah, no, thank you. It would be extremely challenging to do those experiments, but it might be very insightful in terms of even mapping the dog mind if patterns were emerged.
Yeah, exactly. And this is something perhaps we will focus on in the next few years. But first, we have to convince the funding agencies or provide fund for us. Yeah, there's many issues around animal welfare and ethics. Yeah, so hopefully we can come around about this. Yeah. I would argue, even for dogs' welfare, if you want to understand the dog's cognition and behavior, surely at some stage you have to understand the neural mechanism. Yeah. To understand the neural mechanism, you have to use certain techniques such as fMRI or EEG.
I would also have a question. What would be the limitations if we would transfer this model to, let's say, cats?
Sorry, I lost you.
Yeah, my question is, what would be the limitations if we would transfer this model to cats?
Right. Technically, I don't think there's any limitation. You can simply adopt the similar protocol to test cat's behavior. Yeah. But the challenge is more or less the same. So first, we know very little about the neural mechanism and the brain structure in cats. So actually, we know more about cats than dogs, because cats in the past, cats they are typically used in the visual neuroscience. So we know a lot about visual cortex in cats. Yeah, so that's the advantage. The disadvantage is compared with the dog behavior, we know very little about cat's behavior. Yeah. So my answer would be, in terms of the testing, in terms of a protocol, you can easily transfer the dog model to cats. But in terms of interpretation, you will meet another set of challenge. So how can you interpret the findings from behavioral studies without much evidence from a neural mechanism?
Yeah, okay, thank you.
Yeah, thank you.
Please go ahead with questions. Wisam, Denise, Eric, Jamie, Hector, Ankit, please go ahead. Nobody seems to have a question right now. So, what are the future steps of your study that you would like to do next? Are you planning on doing yeah, first I'll start with that and then I'll follow up my next question.
Sorry, you're asking me our next step?
The next steps, yeah. What do you plan on doing next? Or probably you already have done more work. So
yeah, we have quite a few projects and ongoing projects. Yeah, from a human's perspective, we have a few projects and try to understand any similarity and difference in humans to understand human and dog emotion. Yeah. from cognitive strategy and to neural process. So that's from human perspective. From dog perspective, currently we try to understand dogs. We know dogs can differentiate and sometimes understand certain human emotions. But we still don't know how fine this understanding is. It's based on the valence, positive, negative, or based on the detailed emotional category. So that's something we are working on. And also, another thing we are working on is how dogs use this kind of understanding to guide their own behavior. So if you do understand different human emotions and the consequence, so how do you make use of this understanding to change, to guide, or to change your own behavior? So that's our dog projects. Hopefully,
Yeah,
you will
that's
generate some
interesting.
interesting findings.
Yeah, we read, there came a paper out last week or this week that when humans look into each other's eyes, they found similar oscillation patterns in the humans. Are you planning on testing something like this, maybe through EEG? Yep.
We did one study. First of all, we're not doing this. This is a brain-to-brain synchronization. We're not doing this. But we did one study very similar in the past. Because the idea is therapy dogs. People argue as a human, we can enjoy many benefits to keep a dog or to introduce a dog and to schools and to care home, to hospital. But you can imagine there are lots of difficulties to make this practice popular or more common in our society. So the question is, can we use either robotic dogs or video clips to achieve similar benefit? So people look at the eyes of dogs, real dogs, and the eyes of robotic dogs, or the eyes of dogs video clips. As a result, can you introduce more or less similar oxytocin in your bloodstream or prosocial behavior? Yeah. But unfortunately, we didn't find any positive association. Yeah, it looks like you do need some kind of a physical social interaction.
That
Yeah,
is
thank you.
absolutely.
Go ahead, Jamie.
Okay. No, thank you for the talk. That's absolutely fascinating. It's quite an exciting idea. Are you hoping then, like you said, that perhaps understanding how they're seeing us, we can develop methods then that can communicate more powerfully and increasing maybe the bond, maybe even being able to, I don't know, teach them more than they could have done by themselves or something like that?
Yeah. That's a very good suggestion. So the impact is if we can understand the dog's ability to understand the human emotion, perhaps we can change a lot of current practice, especially in dogs training. So one thing probably I didn't mention is in addition to the popular pets, at least in the UK, there are quite a few training centers um, in the police force and in the military. So people train a lot of dogs for various security, military reasons. And some of the training protocol perhaps can be improved. So if let's say we know the dog's capability to understand human emotion, then maybe we can increase efficiency between human-dog communication. So as a result, probably all the training can be more effective, and also you can increase the welfare of this group of dogs.
That actually sounds quite exciting. And I'm also wondering if we had that, if you could teach them habits they didn't know before. Do you know how like where to go to the toilet much faster or
Right.
things like that? I'm wondering. I'm sorry to branch away from the dog for a second, but you mentioning that I've heard about how intelligent dolphins are. Would it be curious for you to do this kind of example with dolphins, because they're supposed to be incredibly intelligent, and maybe communication, validation of the theory would work faster on them, or I don't know. Sorry, yeah, I'm just guessing. Yeah.
That's great. Yeah, I would love to do that. Yeah, if I can access dolphins and get funding for it. Yeah, yeah. I think if I have to guess, I would think most of the social animals will show similar capability to understand human emotion. Yeah, at least to understand valence, positive, negative. Yeah. So far, since our publication, probably 6 years ago, so far people have used a similar protocol to test sheep, horses, cows. I don't think anybody has tried dolphin, but cats they have tried. Yeah, and pandas. So they have tried a range of animals, and they found more or less the same thing. So these social animals, at least they can understand human emotional balance.
Wow, that's amazing. And when you were doing this study as well, did you try it on different breeds of dogs? Like, does a Saint Bernard have the same ability as like a Chihuahua?
We haven't. Yeah, we haven't tried on different breeds. Again, it's a great question. We did get a grant to do this last year, not last year, 2020, 2 years ago. Yeah, but we didn't carry this study because of the pandemic. Yeah. The key thing is, so if you think about the physical structure, different breeds, they do have different physical structure. So if we use the nose length as one example, so typically a long-nosed dogs, they have a narrow binocular visual field. Okay, so they are less good at detect depth, and also their retina is more different from human. They have a visual streak instead of the fovea, human-like fovea. So as a result, physically, this group of dogs, long-nosed dogs, they are not built to interact with human, to see all the details, human face, human hairstyle. So maybe compared with the short-nosed dogs, long-nosed dogs, they are less likely to differentiate different human emotions, or less good to differentiate human emotions. So yeah, theoretically, I would think, yeah, you will find very clear difference in breeds.
Sorry, I think I missed it. Which breed were you working with?
We use a range of breeds. Yeah, we don't specify for breeds. We just test whatever dog we can get our hands on.
I see.
Thank you. I want to welcome Jessica and Dr. Yang and Dr. Mariam to the stage. And if anyone has a question, would you please flash your mics?
I think Ankit, he unmiked.
Go ahead, Ankit.
Thank you. A great talk. I was wondering if dogs recognize themselves? How is their emotional anticipation to their own image? Does that make sense? I'm sorry.
Right. uh, the short answer is I don't know. Yeah. Uh, so this kind of study typically you use a mirror setup. So basically, you put dogs or other animals in front of mirror and try to stick something on your face. So if dogs or other animals can understand the image in the mirror is from me, they will touch whatever you put on your face. So which will tell you they have a self-awareness or human-like theory of mind. Uh, so that's a typical setup. I know many people have tried, but so far we don't have a consistent conclusion about how likely dogs can have a human-like theory of mind or self-awareness. But my personal feeling is, if you design your experiments carefully, my personal feeling is you can observe similar things in dogs. So very likely they will have a human-like or very crude human-like theory of mind in them.
Okay. To follow up on that, how about, for example, dogs, or in this case, any animal perhaps, uh, they are responding to humans or their other dogs because they are obviously have been, used to the species, in the sense that they, in from your data, you show that dogs look at other dogs' ears more than they do of humans, knowing that they, you know, differentiate among the species essentially. How about, and I'm not sure there has been a study on it, but in your view, how would a dog view to a species, let's say they have not come across? For example, in a hypothetical experiment, if a dog has never been exposed to a cat, but is now exposed to a cat, what is its first default ways of expression? Essentially, he or she has not trained its mind yet, but what would be the first default way to go about it?
Great idea. Great idea. Uh, I don't know. I don't know the answer. But you will find analogy in humans. So, if I extend your question a bit, so your question is about whether we have dogs have some kind of innate template about
Yes.
the face and about
uh,
the emotion.
yes,
Yeah.
that, for example, and this is essentially pertaining to, for example, if a dog has not been exposed to a baby, but
Mm-mm.
comes
Mm.
comes in touch of a baby first time, how,
Mm-mm.
I'm just
Mm.
curious, how do they train their mind? What is the default state of mind that they start from, and
Mm.
how do they train it from?
Mm. Uh, as far as I know, uh, nobody has done research on dogs. Yoichi Sugita in Japan, he did something on monkeys. Okay, so if I use his study and my understanding about human infant study, my prediction is yes, dogs will have some kind of innate representation of the face. But how accurate this representation is? So for instance, can dog differentiate without experience? Can dog differentiate face species from cats, from human, from dogs, from dolphins, from horse? I doubt they can do that. Yeah. So they may have an innate representation of a face. So that's how face will look like. This is how important it's going to be. But I doubt they will you can differentiate which species they will come from.
Uh, Pretty cool. Thank you.
I had a question. First, great presentation, very interesting. I really like the fact that you used language naive dogs for the experiment. That really helps with the sorting the signal to noise. I was curious about how good they were in terms of sorting that type of signal to noise when the facial cues were different from the words. So good words, bad facial cue, vice versa, or even flat facial cues and flat tones. And do these mechanisms exist in undomesticated wild canines?
Great question. We did one follow-up study. We didn't publish the results because of sample size. So it's a match and mismatch. So the short answer is we don't know. We don't know how fine this discrimination ability is. And we don't know what kind of properties dogs can use to extract the emotional cues from vocalization. So do they use a pitch? Do they use a frequency, base frequency? Or do they use intensity? We don't know. Yeah. But our initial finding from that study is they don't make good differentiation about different vocalization within the same valence. So if you call dog with, let's say, a happy face, happy vocalization, so come on, or with a surprised vocalization, come on, yeah, they don't differentiate. It didn't differentiate in our pilot study. So same thing is for the negative valence. So if you call the dog in angry tone or in a more fearful tone, they don't differentiate this. But they do differentiate between the positive and negative valence, and they differentiate the emotional vocalization from the noise. So that was our pilot study at that time. Yeah.
I see. And then what about, do these mechanisms exist in undomesticated wild canines?
If I have to guess, no. Because we haven't done the same study. And so what we did is a similar study in the past. It's something called looking bias. Okay. So when human look at a face, we always go to the left first. So we call it left gaze bias. So this preference is driven by our understanding of the facial information. So we found similar thing in pet dogs. So which means the dogs, at least pet dogs, use the same strategy to understand a human face. So after that, we did the same study on domestic wolves and on a group of greyhounds. So domestic wolves, they are raised by humans. Even genetically, they're more away from humans. And we found similar preference, left gaze bias in domestic wolves. But we didn't find the same left gaze bias in greyhounds. So greyhounds, I'm sure you know, greyhounds and they are pack animals. They have minimum interaction with human. So from these findings, I would predict, the experience is very important. So if you test the same protocol in a wild canine, I doubt you will find the differentiation for human emotion.
I see. Thank you so much for your answers and your presentation.
I had another question, and it relates to the, for lack of a better term, the sensory loading of the dog experience. I've had a few dogs, and I've always been curious about whether I could distract them with images in a mirror or not. And I've failed miserably to get any kind of interest out of an image in a mirror in any of the dogs I've had. That's purely anecdotal. But in terms of trying to understand that, I understand, and please correct me if I'm wrong, that um, the dog visual cortex and visual system perhaps isn't as relied on as much as smell and auditory cues. And, sound or smell wouldn't be coming through a mirror. And I'm wondering if these kinds of experiments in terms of, say, auditory cues and picking out the emotional content of voice inflections might be a cleaner signal, or I don't know if cleaner signal is the right phrase, but
mm,
in terms of the
mm,
using other types of sensory loading to
mm,
or
mm,
whether they look at gait more. You showed evidence that they look more at the body than the
mm,
eyes.
mm.
Any comment
Yeah,
on that?
mm. Yeah, that's a great question. Yeah, I didn't mention this. Uh, so all of our studies, not just me, and people working in this area, we have a fundamental flaw or basic assumption is that we assume the visual and auditory cues will play a high weight in dogs' sensory processing. So that's our assumption. Okay, so we use a human as a baseline or benchmark. So we assume, like humans, visual and auditory cues will play an important role in dogs' communication. So that's our assumption. So like you mentioned, actually, if you think about the dominance of the sensory communication, so perhaps visual cues they don't play a big role in dogs' communication, especially in dog-dog communication. Okay. So in terms of sensory sensitivity, olfactory cues, of course, is the most sensitive. And dogs have much higher sensitivity to auditory cues compared with human. Yeah. So it is likely, it is not likely one communicate with, especially with their own species. Yeah, they probably use other channels, olfactory and auditory channels to come. Yeah. But the counter argument is you have to consider the human's role in this communication. So if you think about human-dog communication, because humans are vision animal, yeah, so we don't have we don't have very high sensitivity and to auditory inputs, and some people do, but most people don't have very high sensitivity to olfactory inputs. Yeah. So as a result, so maybe from dog's perspective, yeah, they may have adapted a certain strategy only works for human-dog communication. Yeah, but yeah, it is entirely possible that you will use a different sensory channel to communicate with each other.
Yeah, I think that's really interesting to consider, that the input versus output consideration here. That for them a different input is important than for us, but they still overcome this hurdle by generating an output that makes sense to humans and adapt in that way. That's quite impressive, I think. But Dr. Mariam, you had the question, and LT joined us on the stage. Welcome.
Thank you, Katerina. Hello, everyone. Hello, Dr. Guo. Sorry, I've missed most of your presentation, but I will be watching the replays again. But, it's really interesting line of questioning, and I'm really enjoying the answers. So based on, some of the points from some of the other speakers, I was wondering if in your future studies, when you're comparing different breeds of dogs, how do you intend to, first of all, account for the variability within different breeds? I'm thinking with regards to maybe how they communicate or how they relate to humans. And thanks to selective breeding, there's a lot of dog breeds that have been bred for different purposes, but might have different skill sets over other breeds. For instance, greyhounds are race dogs,
mm,
chihuahuas are more like
mm,
lap dogs, German shepherds are more of hunters, um, so on and so forth. So some might have maybe better hearing, uh, faster speed, better scent, um, better sense of smell, basically.
mm, mm,
Uh, so in that variation, how would you attribute certain characteristics to the general species, the general canine species, and would you be able to filter out what if there may be different communication or
mm,
values, let's say, for different breeds of dogs? I hope
mm.
that makes sense. Thank you.
Yeah, definitely. Yeah. Yeah. It is an area we haven't studied systematically. So at the moment, we just treat the dog as one single group. Uh, so all the studies we tend to recruit, if you like, a representative breed of dogs or common breeds in our society to test. So as a result, we hope we can generalize our finding to a bigger population. So that's our current approach. But like you mentioned, I do agree they must have a huge breed difference, and in terms of probably for all the sensory processing abilities. Yeah. So I think that is something we have to work on soon or later to have a clear picture about dog as a population. But at the same time, I think for the basic sensory communication, like understand human emotion balance or even some basic emotion categories. For this kind of very basic sensory communication, my guess is it will be quantitative difference between dog breeds, not qualitative.
Yeah, that makes sense. Thank you for your answer.
Yeah.
LT, did you have a question for
Yes,
us?
may I have a question? May I ask a question? Uh, can you hear me all right?
Yeah, I can. Yeah.
Okay, good. I totally enjoyed the presentation. My question is that I'm not sure if I take home the correct message. You said the dog doesn't recognize the emotions, meaning that if I'm like scolding her, like I have a dog, I had a dog before, now this one, the one in my picture, is my current one. So when I want to get her back home, it doesn't matter how angry I get, it's not effective. So so it's the noise, but then you said the emotion. I do put the emotions. Like I said, you come home, like
Mm.
I put like angry, like I really like I mean it this time. She doesn't respond to that. But you mentioned the noise. A noise of like what kind of noise we're talking about? The car noise, like the man's voice, versus the women's, like a kid's voice. Can you expand on that a little bit? Thank you.
Uh, the noise we use in our study is a Brownian noise. The standard way to control vocalization as a whole. We didn't differentiate between pitch, between intensity, between base frequency. Yeah, so it's Brownian noise. So our current findings can't really address your question. So if I have to guess, probably one possibility, your dog has a free spirit. Yeah, so it's more likely
Okay,
to
I got it. Thank you.
enjoy his own
Okay.
behavior. Yeah.
So she comes home
Another
whenever she wants
possibility.
to. Yep.
Yeah, there's another possibility is your angry probably is not typical or not representative. And to the angry vocalization, this dog has heard before. So maybe you're changing your pitch, changing your frequency or intensity. Yeah. So maybe he can learn a new association.
Okay.
That's my guess.
Okay, great.
Yeah.
Thank you so much. Yeah.
I would like to interject on behalf of Chihuahuas everywhere. I grew up with a little Chihuahua, and she was fearless.
Right.
And she ran everywhere with me, and she would bark at large dogs. And yeah, she was very spirited. I think it's all upbringing, more environmental. Thanks.
Yeah. Yeah, it's a shame we're far away from each other. One of my PhD students, she is working on the emotion regulation strategy in dogs. So what she found is attachment style between owners and the dogs have a huge impact on dogs' strategy to regulate their own emotions. So if we are close to each other, maybe I can ask her to test your dog.
Could you perhaps speak a little more about the two-way communication between dogs and humans? Thank you.
Sorry, could you repeat your question?
Sure.
I lost your sound for yeah.
Sure. So it sounds like you do want to study two-way communication between humans and dogs. And I was wondering if you could speak a little more on your perhaps the types of studies. Yes, sir. Thank you.
Yes. So my group is working on the two-way communication. How dog understand human from scientific background. That's more comparative cognition. So how dog understand human, and also how human understand dogs. And so from humans' perspective, we can do many different experiments on humans because they're easy to recruit, and also we can ask them to do many things, and we can torture them in eye tracking, fMRI, EEG, different equipment. Yeah. And so in terms of the detailed projects, at the moment, we are concentrating on the emotional understanding. So how humans understand the dog emotion? Can you really understand different emotion categories? And if you can, what kind of strategy you will use? So do we use the same brain or same neural circuits to process human emotion and dog emotion? Or we use different strategy to process dog emotion only? So that's the kind of work we are working on.
So, if I may, I guess we are almost at the, we are going over an hour. So, but if I may add another comment regarding, the brain activity patterns, that they are different. And since you said, and we just, based on the reflections of the Q&A, so basically the input for dogs is most likely very different from the ones from humans, because humans are more focused on the visual system and they have the frontal eye position and then the dogs generate then an output that is adapted for us. So then it makes really sense that their brain activity patterns are different looking at the brain regions that process them. But could there be a commonality in maybe not the brain regions, but a commonality in when activity patterns are going on, maybe the timing, and then you know, like, is there maybe a difference but also a commonality that we didn't detect? Or how would we look at this adaptation towards the human? Is there a way to, for example, have dogs that haven't had too much exposure yet to humans and then see over time how their brain activity changes while interacting with humans, or let's say with another organism, like of another species? Maybe they are used to humans but not used to cats yet, and see how over time maybe the brain activity changes with exposure to another. Maybe it's not just limited to humans. Maybe dogs in general are good at adapting towards other species behavior.
Yes. Yes. Brilliant idea. Yeah. My suspicion, yes. If we have suitable technology, I suspect you will find similar things. It's something we call perceptual layering, or brought to differentiation process. So basically, the idea is in dog's brain, they must have some kind of circuits or template of circuits, neural circuits, to process some meanings of sensory inputs. So for instance, they must have some kind of template to process valence. Okay, so this valence could come from vocalization, could come from olfaction, could come from visual. Okay? It's just which sensory cues can activate these circuits. So if we have a suitable methodology, we have actually. It's just how likely you can use them on dogs. So I would guess you'll find this something similar to the perception layering we have found in monkeys. Yeah. So you can introduce a different sensory inputs with the same abstract meaning, and through either perception learning or just an increased amount of exposure, so you can refine the pattern of neural activity in that circuits.
Yeah, exactly. So the ideal experiment would be, which would be maybe cruel. No, well, it wouldn't. Maybe just dogs behaving with each other. You would have a group where the dogs just get exposure to dogs. You have another group. A dog starts getting at some point exposure to humans, and then some other species, maybe 3 different species, and then you can pinpoint towards the circuitry that adapts towards other species. And I think the insight would be really interesting also for humans that suffer from adapting more precisely to new environment and also other humans. If we could learn from that, maybe that would be a really great insight.
It is. Yeah, I totally agree with you. Like I mentioned earlier. Sooner or later, you have to move beyond simple behavioral measurements. You have to understand the mechanism.
The other thing what would be helpful from that insight is to train in the future AIs and robots that behave with humans and use that information how dogs approach this problem to train artificial neural nets and robots that then have an easier time adapting to us and our environment. I think that would be another way to use that knowledge and apply it.
Yeah, definitely. Yeah, very interesting idea.
Yeah, with that, if anyone has any questions, please go ahead. We've been going for almost an hour and a half. I wanted to check with you how much time you have left for our questions. Yep.
For me, probably I can stay for another 10 minutes. Yeah, to have another appointment at 7:30.
Yeah.
In my time. Yeah.
Yeah, it's getting late for you.
Yeah, thank you very much. Yeah, I think there's many interesting questions. Definitely, I've learned a lot from you guys. Yeah. So in my mind, I'm already planning some future experiments based on some of your questions.
Oh my God, I want to hear updates. Please keep it. It's so interesting, your work. I wish I could be there and see it be a fly on the wall.
A dog on the couch.
Yeah, you're welcome to join us in the future.
Oh yeah, that would be wonderful. I would love to. Yeah, anyone has any last question? Please go ahead, everyone. Somebody in the audience, let me bring you up. Oh, it didn't work. Sorry. I tried to bring Sabrina up, but it didn't work.
Me too. Where did Sabrina go?
I think her app crashed or something. When we were trying to bring her up, it crashed probably. Anyone else in the meantime? Maybe Sabrina will try again. Okay, if not, I'll let her know that she can message me, and then maybe I can, if it's something that I cannot answer, I would forward the question to you. So again, thank you so much for this amazing presentation, and your work is really so interesting, and I love how you approach your experiments, designs, that you questioned previous assumptions. It's always wonderful to see that, and that it's working out. And yeah, please update us with your
sure.
ongoing experiments, and come back anytime, please.
Yes, thank you very much. Yeah, feel free to contact me. You can find my email address. Feel free to contact me if you have more questions or more suggestions for the future experiments. Yeah.
So I hope you have a
Thank
lot
you
of
very
fun.
much,
Oh yeah,
Professor.
go ahead, James.
Oh yeah, no, I would just
Thank
wish
you.
I was just saying thank you very much, and give the Special Science Society best wishes, Katharina.
Jamie, you're close by. You can go and visit and help out.
Ah, that's a good.
That can be arranged.
That's a good idea.
You can be the representative of Science
Science
Society.
Society. Yes, I will be. Give me one of the T-shirts.
Yeah, I'd be happy to help out if you're looking
Oh
for
yeah,
volunteers.
Dr. Mariam, you're there too.
Oh,
I'm
you too as
jealous
well.
now.
I'm
Yeah,
not there,
I'm
but I can be on my way.
yeah, I'm good at handling dogs, so
We're sending a
You now have a
contingent.
staff,
We're
Professor.
really nice people too.
Okay, so you have many volunteers. So whenever you need somebody,
Yeah.
you know how to contact us. Okay.
You have a staff now.
Yeah, some free labor. Well, it's fun, right? It's better than watching TV, I guess. So for sure.
You come here, speak, and you leave with a fan club.
Thank you so much, Doctor.
Yeah, thank you. And thanks everyone for coming. And please follow the club if you like rooms like this. And we'll have Dr. Guo back for sure. And we have tomorrow a guest speaker who will talk about her new design of machine learning using molecular orbital based machine learning. So I think it will be really a really interesting room. And on Sunday, we'll have the weekly recap where we shortly try to stay around an hour and summarize what we learned here throughout the week on Science Society. So if you missed rooms, or if you would like to, if you missed links of papers, we will share the link of the paper again and just shortly summarize what the research was about that guest speakers presented here. So thank you everyone for coming, and we'll have also a very exciting week ahead. We will have every weekday a guest speaker next week again. So yeah, if you click on the Science Society Club, you should be able to see the schedule. And yeah, thank you so much, Kuhn, and I wish you all the best, and see you back sometime soon, hopefully. Okay, we'll close the room in 3, 2,
Thanks,
1.
everyone.
Bye. Bye,
Thank
Bye.
you.
everyone.
Bye.
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 Bye.